welcome to part 2. We're going to pick up with question number 5 on the practice problems worksheet. So taking a look at that one, we're going to have trapezoid WXYZ shown above. How much greater is the area of the trapezoid than the area of a parallelogram with the side lengths A and B and base angles of 45 and 135? So what the biggest problem with this is translating actually what they're looking for. We're looking at the trapezoid right now. If I draw this line in right here, that's going to create a parallelogram. And here's the thing about that parallelogram. We know parallelograms have opposite sides that are equal, which makes that A. And because of this being 45 degrees, this is going to end up being 90 degrees and 45 as well. So this is actually going to become A as well. So what we need to do is we need to figure out how much greater is the area, aka what is the area of this triangle. So the biggest connection is figuring out this is a 45, 45, 90 triangle. But because trapezoid's legs, in this case, the legs of the trapezoid are going to end up being equal, and because a parallelogram is opposite sides that are equal, that's the reason why we can conclude this is a 45, 45, 90 triangle. Area of a triangle is 1/2 base times the height. Well, in this case, the base and the height should always be perpendicular to each other. So we're going to make the base A, the height A. So this is going to be 1/2 A squared. So this is going to be letter choice A for number 5. Going on to number 6, tough diagram to interpret here, but basically what we're looking at here is a glass vase that is hollow in the middle. Think of it like almost like a bread bowl you would get at Panera, right? I want to find the area of the bread bowl, not the entire bread. Obviously, the part would be taken out, the void would be taken out where you would put the soup or something like that. So in order to figure this out, similar to the question we looked at before, whenever you look at a volume or an area that is irregular, typically we want to look at the area of the entire shape. So in this case, the entire box as if it was a closed vase. And then we're going to subtract the area of the void or the air, the empty space in it from it. So that's exactly what we're going to do in this question. In order to find the volume for this, we need to find the base, the width, and the height of this. And the good news is by looking at this, we can actually tell that this is 2 and this is 2. I'm looking up here. And the key word that I took out of this question, by the way, is that it is a square base. So that's the reason why I know the base and the height are both 2. The height here is 5. So the area of the, volume, I should say, of the entire thing ends up being 20. Now, finding the volume of the empty space is going to be the tougher part. I'm going to, again, highlight this in blue. Let's actually put it up here this time. Base, length, and height. The height is going to be the first thing. I think that might be the easier of the things to see here. The height of this is going to take away this 1-inch area from it. So instead of being 5 inches tall, it's actually only 4 inches tall. But in order to get the square base now, we have to take a look at an aerial view of this. If I take an aerial view of this, if this whole thing is 2 and 2, notice that they gave this 1/4 here. That means there's a 1/4 of an inch on each side here. Well, if I take a 1/4 of an inch right there and a 1/4 of an inch from there, that is a 1/2 of an inch. Therefore, the length of this square is 1.5. I'm going to say 3/2 just for easy math here. So the base is 3/2, the width is 3/2, and the height is going to be 4. Well, when I multiply all of that together, what I'm going to end up getting here is an answer of 9. So 20 minus 9 is going to give me an entire volume here of 11. This was a multiple choice question, so that's going to be letter choice D. Okay, we are moving on to question 7. Question 7 and question 8 are both utilizing the idea of a circle, the equation of a circle. So a reminder, I believe this is something that is in Algebra 2. The equation for a circle, there we go, is this. X minus h quantity squared plus y minus k quantity squared equals r squared. Here's the important things to take away from this. The h and the k are going to tell me what my center is. Notice I did not include the minus, all right? That's important to note. So, and then the r right here, not the square, that's going to be my radius. That's going to be important as we move down to this question. So the graph of the equation is a circle. If the center of the circle, I'm going to highlight this first part in yellow, is translated 1 unit up, and then the second part here is that the radius is increased by 1, we want to know what the new equation is. Well, let's start with the original right here, okay? Where is the center of this occurring at? Well, according to our idea up here, this is going to have a y value of -1. Remember, we don't include the negative signs as when we indicate our center. So the y value is -1. The x value, well, there's no number next to it. So we would have to assume that it's x minus 0. So the center of this is at 0, -1. Lastly, the radius here is going to not be 4. Remember that we don't include the square when we do this. The radius is going to be the square root of that, so the radius is going to be 2. So now that we know that, we can start to look at the yellow and the green highlighted pieces down here. If the center of the circle is translated 1 unit up, well, if we move the circle 1 unit up, we are moving its center up 1 unit, which means the center is going to have its y value increased by 1. The new center then has to be 0, 0. If you take that part away, you can already eliminate C and D because these centers are at -2. Now, the last part of this is that the radius is increased by 1. Now, this is where it can become confusing. It's not that the 4 is being increased by 1. 4 is not the radius. 2 is the radius. So if the radius is increased by 1, that means the radius is now 3, which means that r squared, the part that you'll see in the equation, is actually going to be a 9. So letter choice B is the correct answer here. Be very careful with that 5 because that's kind of tricky when you're looking at that. The next question is also talking about the equation of a circle. And as we look at this here, it doesn't look anything like what we have over here. We need it to look like what I had shown you on the previous question like this. And that's exactly what we're going to have to do for this question. We need to find what the radius of the circle is, which means I need to find that r squared. What we're going to do here is utilize something called completing the square. So what I'm going to do is let's write the x values in red. So x squared plus 8x plus, and I'm going to leave a blank right there, plus, and then we're going to do this part in blue, y squared minus 6y plus blank, and this is going to equal 24. Now, if you don't remember completing the square, I would definitely YouTube or look it up, or you can ask me later. Completing the square says we're going to take this 8, we're going to take half of it, and then we're going to square it. So half of 8 is 4. 4 squared is 16. Now, if I add 16 to one side of an equation, I must add it to the other side. Otherwise, my equation isn't balanced anymore. Same thing here. I'm going to take this 6. Actually, it's -6. Cut it in half, which is -3. When you square a negative, it becomes positive. So this becomes a +9, which means I add 9 to the other side. Now, look, these are going to factor really nicely into that form that I just showed you on the previous question. However, the question just cares about the radius. So I'm really just concerned about what these numbers add up to, and these numbers add up to the number 49. 49 is not the radius, as I remembered telling you in the previous question. It's squared, which means this is our r squared value, which means my radius is actually going to be equal to 7 here. Okay? A few more questions to go. These are going to utilize some trigonometry concepts here. So this is, again, going to more algebra 2 ideas. We have this idea that triangles are similar to each other, and they tell you that the cosine of r is equal to 0.263. Now, keep in mind what cosine means. Cosine of r means that the adjacent over the hypotenuse, that ratio when you divide them, is 0.263. Well, they're asking you for cosine of z. Cosine of z is right here, which is adjacent over hypotenuse. And if you remember way back from the first video on our first question, if I take adjacent over hypotenuse of the first triangle, which I'm putting in black here, and I set it equal to adjacent over hypotenuse of the second triangle. Let me put a little sub 1 here so we don't confuse what we're looking at here, and we'll call this a sub 2. Okay? What we know is that because the triangles are similar to each other, that means that their ratios are equal. We know this is 0.263. That means this has to be 0.263. So cosine of z is also going to be 0.263 in this question. Again, using similarity, same ratios. That's the key word here. A few more questions to wrap up. Question 10, we are given the coordinates of point B here as -√2, √2. Another third question we've come across here where we're going to have to use a special right triangle. That means if I draw a triangle here in this origin, I'm drawing the triangle right here, but I'm zooming in to show you a bigger shot of it. That means that this is -√2 and this is +√2. This is a 90-degree triangle, which means this triangle is a 45, 45, 90 triangle. That's really, really important because the angle they want you to find, AOB, and this is zoomed in here, is this angle right here. Well, the 45 degrees and this red angle right here have to make a straight line. Straight lines measure 180 degrees. This angle is 135 degrees, and we've answered our question, except the answers are in radians. So we need to figure out what the radian equivalent here is going to be. The quick way to convert from degrees to radians is you're going to take degrees, multiply it by pi over 180, and that's going to give you what your radian measure is going to be. So the answer here is actually going to be 3 pi over 4. Quick side note, if you're curious, to go from radians back to degrees, you take your radian, you multiply it by 180 over pi, and that's going to give you your degree measure. So these are just some quick reminders to switch between degrees and radians on the SAT. Going down to question 11, we have another question involving trigonometry. In this case, they're asking you for the relationship between sine and cosine. They ask this question in many different ways on the SAT, and you're almost guaranteed to come across it. One big thing I want you to remember is that the graph of sine, this is going to trigonometry now, is going to look something like this. And the graph for cosine looks something like this. And so they look like they don't have anything in common with each other until we take the idea and I take this blue line right here, I'm going to take now, and I drag it a little bit to the left. If I drag it to the left, now granted, I drew this by hand, so it's not going to be perfect. But you get the idea that this is going to be the same thing as the sine curve, which means if I horizontally shift it by some amount, that's going to tell me that the equations or graphs are going to actually be equal to each other. That's what this K value is looking at. They're looking at what the horizontal shift is going to be. So how much does a horizontally shift? Well, from here to here is what I'm looking at. Or you could look at it from here to here even. That the horizontal distance is going to be pi over 2. So that pi over 2 is going to be my horizontal translation, which means the answer here is C. The other way that I could come across maybe explaining this before we move on is that I know right here, this is the cosine of 0. Well, the cosine of 0 is equal to 1. And then the value right here, okay, is also 1. Well, what value is that? That's sine pi over 2, and that's also equal to 1. So there I've shown that if you add or subtract pi over 2, you will always have sine and cosine matching each other. Try that at any radian value, and it will work. So this is something really important I want you to take away from this. Another interesting thing before I go on to our final question is that the cosine of an angle will always equal the sine of 90 minus that angle, the complement. Part of the reason why is if you look at a triangle, we'll call this x. This is the adjacent, this is the hypotenuse, this is the opposite. Well, if I take 90 minus x, that's actually going to be this angle right here. And so cosine of x is adjacent over hypotenuse. 90 minus x, its opposite side is actually here. Its hypotenuse side is here. So we're using the same two sides of the right triangle in order to figure this out. Final question comes from Algebra 2. Which of the following is equal to 1 plus I over 1 minus I? The idea we want to use here is something called a conjugate. We can always talk more about this if we need to later. The conjugate means I'm going to multiply this bottom term by the same thing, except I'm going to put a plus sign there instead. So it's going to be 1 plus I instead of 1 minus I. We're going to go ahead and we're going to FOIL this out. Down on the bottom here, we're going to get 1 minus I squared. On the top, if I FOIL this out, I get 1 plus 2I plus I squared. The next thing we have to take away from this question is that the square root of -1 is what's equal to I. Therefore, I squared is just the square root of -1 squared, which is -1. I'm going to take that and plug that into this question. So I get 1 plus 2I minus 1 over 1 minus -1, which is actually 1 plus 1. We keep simplifying this. The two 1's up at the top cancel, so I'm left with just 2I. The bottom is just 2. And after all of that work, those 2's cancel, and I'm just left with a lonely I. That's going to be letter choice A in this problem. So that will conclude the additional topics of math video. Please feel free to go back to either of these to look back again at any of the questions I've gone over. Thanks again for watching.